and welcome everyone to this 3D update. I'll share some slides and we'll be giving you access to the slides along the way. So we'll just start off and we have a few places you might want to join in and try from home. So hello everyone. Three of us will be presenting today. Julie, you want to start in order?
Oh, yeah. Hi. So, yeah, my name is Julie Winchester. I am one of the editors for IIIF. I'm also the technical director for the Morphosource 3D data repository at Duke University, and I'm in the evolutionary anthropology department there. Yeah. Tom, do you want to go next?
Sure. My name's Tom Flynn. I'm a UK-based consultant focusing on 3D, cultural heritage, publishing, open access, storytelling, and everything related to those kind of things.
Thanks very much. And I'm Ronald Haynes, based at Cambridge University in the UK, and one of the co-chairs of both the 3D Community Group and 3D Technical Spec Group. So the three of us here cover a lot of 3D, and there are many people joining the workshop who are a part of it as well. This is a rough schedule. Sorry, UK times. Please adjust for your time zone. And that it's a rough idea. So we'll get into the various areas of the community group, CG, have some discussion, and get your input and share more about how that has evolved and where we go in the future. The technical specification TSG group, have an update about that and some interactive experiments, time permitting, some you can take away as well, and open discussion again, where we're headed with all this and what it will mean and changes to the specification for IIIF work. So one of our group, Rob Saunders, in a recent meeting mentioned that this is one of his takeaways from years working, that what makes IIIF work and work well is the combination of community, of standards, of software, and of collections. And we see that very well represented in the 3D work, but all through IIIF, that we come together as a community, we work on these standards and apply them in our software and use our collections to share and express in this interoperable way. Some of you have seen this. It's based on what's on the website, but it gives you some idea of sort of how it all works, and in particular, that it's built on open web technologies. So that's important in terms of interoperability, universality, sustainability. And so those are some of the technologies being used, including in 3D work. 3JS and Babylon.js are JavaScript frameworks, libraries that are used in a lot of our viewing environments. And there's more to come, and it's all modular, not monolithic. Our goals, a draft, a release candidate of presentation API 4, Prezi 4 for short, including 3D support, and editors will, so the editors are working on that, as well as the TSG, and editors will put it in format, and we are aiming for a release candidate, first one for our annual meeting coming up in Leeds in June of 2025. The TSG provides recommendations for editors with sufficient time for specific specification drafts. It does take time to put it all together, and anticipating what comes after, adoption, requirements for implementation. And so that'll be part of where we're headed together as a community. And so let me stop sharing and turn it over to you, Tom.
Thanks. Okay. So the community group has been going for quite a while now, and unlike other groups within IIIF, I'm given to understand that it's fairly unusual to have a community group running at the same time as a technical specification group. Normally there's a a graduation from one to the other, but it's actually been very useful to maintain the community group, because even though that people have been making and creating 3D data for a long time, there are developments and changes happening in the field, and also still even now kind of fairly few agreed upon standards for anything really. So it's a great place for people who are interested in 3D as applied to cultural heritage to get together. It's a open space for beginners and veterans to review solutions, discuss international projects, tools, make contacts with other researchers and developers, and showcase creative and innovative uses of 3D. So we've got 370 members in a Slack group, and we meet every 4 weeks on a Thursday. And if you're not already coming along to them and you're interested in this work, then please do join up and say hi. There's a link, actually we'll put a link in this when we share the presentation to the IIIF website. So I'm just going to go through kind of, I reviewed kind of the minutes from the meetings over the last year, November 23 to November 2024, and just pulled out sort of some of the things that have been going on. So there are often a lot of discussions about various topics. It could be a particular thing that has happened recently, or a particular issue that somebody's facing or interested in. And so we kind of encourage discussion and sharing of different ideas. Obviously, we regularly feedback the TSG, the Technical Specification Group, updates to keep people up to date on what's actually being done with the specification and the hard work that the team over there is putting in. There's been discussions about 3D data optimization, because we're talking about publishing online. Also kind of taking a step back, discussions about color management in 3D digitization, especially relevant when you're kind of comparing, or hopefully comparing like for like 3D models from different collections, how things will look the same or different when you put them side by side. Discussing specific use cases for 3D, and from that discussion, actually way back when, some of the user stories that the TSG have been building on were developed as well. And then other things like industry trends, outside of cultural heritage sector, looking at how other industries are using 3D. And then, like I say, anything else that comes up, and if there's something that you're interested in, then please do join and strike up a conversation within the group. We encourage it. There's lots of 3D viewers in the world and online, and so the community group regularly has kind of links shared in Slack or demonstrations in on one of the calls as well. So these could be from active IIIF 3D viewers that are being used to develop the IIIF 3D spec. So ALEF, Universal Viewer, Compact, the Smithsonian Voyager, X3D viewer, but then also looking further afield at other interesting viewers, such as Kintsugi 3D out of Minneapolis Institute of Art, other industry viewers like Adobe Substance, Cesium, all the ones listed here. And the idea is to kind of keep an eye on developments and features, because some of them can be an inspiration for the work that the IIIF 3D groups are doing, but also to test in one 3D viewer, how does this 3D model render, or which way up does it show different things, testing them out and seeing how editors and 3D viewers react. It's also a good place, a community group, for sharing experiences and learnings from events that maybe not everyone can go to. There's many events related to, now more than ever, I would say, 3D, VR, AR, AI, spatial content for cultural heritage, and they happen all over the world, and not everybody gets to go to them. So it's actually a good place to listen in and hear some of the developments that people have gleaned from chats and presentations at these different events. Obviously IIIF events, but other events like 2 and 3D at the Rijksmuseum. SIGGRAPH is a much bigger, broader graphics convention in the US, and then smaller events, bigger events, specifically cultural heritage and otherwise. So a good place to keep abreast of what's happening. We've also had lots of demonstrations, either of new technology that people are tinkering with, or projects that people are working on. So, for example, we've had demonstration and discussions of Gaussian splatting, which is a slightly new 3D rendering format. It's not anything to do with the TSG work at the moment, but it's gaining popularity in all kinds of areas. We had a nice demonstration of a IIIF demo using Apple Vision Pro. So kind of this is a VR headset, and pulling in different 3D content based on the draft manifests. I pulled together a chess set because we've been talking for a while about how to describe different use cases for a scene in 3D, and pulling in multiple different 3D models and placing them in specific places. And we talked about chess sets before. And so now that's kind of made as an open resource that's kind of been published. There was another demo of fabric animation as well. And we, again, welcome any more demonstrations of things that you might be working on, or even things that you've seen and you think are relevant to the conversation. More rather than kind of more, let's say, ad hoc demonstrations, we've had member and guest presentations on a number of themes. So a review of photogrammetry apps, so smartphone, smart device apps from the Deutsche Museum, a presentation that I'd given previously at Europeana about storytelling with 3D. We had a nice presentation from the commercial company Histovery, who work on immersive AR exhibits, and Hell of Us Innovation, working on a metaverse solution. And we welcome any more suggestions for people that might be good to tap for an invitation to the group. So please do let us know if there's something that you think other people should know about. We have also been making contact with other like-minded projects that exist in the space. So one particular one is the OpenUSD group. So USD is a file format that aspires to contain as much information about a piece of 3D as possible. So everything from animations to annotations to audio, and what else might it be in there? Metadata, for example. So there's similarities with the idea of a IIIF manifest and a 3D model compared to this open standard that's being developed by Pixar, Apple, NVIDIA, and other industry players. Currently, the focus is on those industries. So, for example, visual effects, film, manufacture. And so we've made first initial contact. We presented to the Academy Software Foundation OpenUSD working group, so they know about us, and we're working towards getting a reciprocal presentation and keeping aligned, not necessarily aligned, but aware of the two different kind of threads of work that are very similar in some ways. And then more recently, if you're not familiar, Sketchfab is a publishing platform for 3D, and a lot of museums across the world use it to publish their cultural organizations, universities, science organizations use it to publish their 3D data online. There are some kind of ongoing changes to the platform, updates that are kind of indicating that the platform may be drifting away from a kind of community-based portfolio site, which is essentially what a lot of organizations use it for, to more of a commercial marketplace. And whether these changes go well or go badly, we can't say, but it is a good indication of how reliant I think the heritage sector has become on this one commercial service, and how little control that heritage users have with regards to what happens. So we've actually we're trying to get on a call with the team at Epic Games to just discuss a little bit, how best to proceed, what's the best future kind of direction that heritage organizations can take to not necessarily reclaim, that's not the right word, but to make sure they don't lose any data that they have created using this platform. So not necessarily the 3D models themselves, they're probably backed up, hopefully, on hard drives anyway, but things like annotations and tagging and categorization, how might that be packaged up and downloaded? So we'll see about that. And if you're interested in that conversation, do let us know. We can update you. And now for a brief experiment. Ronald, I'm going to hand over to you again, if
Please
I may.
do. Thank you. So in the chat area, I'll just put something we prepared earlier, actually a set of the slides that have some links that are relevant. And now I'm going to share my screen again to show a little more. So in that set of slides, you'll see this slide number. And on the next page is a selection of places where you can get 3D models. Sketchfab has been mentioned, Tom just talking about it, and questions of the future, but it's a place that has lots of material, including, and when you search, you can ask for CC0, in other words, readily usable, or you can search by license type for things that you are able to use without further permission and so forth. Morphosource, Julie had mentioned, is a place that has a big repository of things related to natural history, the life sciences, and increasingly cultural heritage materials, and more can be said later this time. Ireland and France in the middle are two nations that have led the way in having national repositories for 3D materials, resources, and Ireland has had material that's been used in a Star Wars film that they had already digitized from one of their remote islands and so forth. Smithsonian has a long-running 3D program, and you can access it through their 3D.si. And it's an interesting example of how a cultural heritage institution will present 3D material. And there's an example from Europeana, and that link will take you to their repository, the 3D material in there, which is 6,000 some, and counting. They vary as to how friendly they are and trying to get data out of them, but you have to embed their viewer or can download a model, etc. So have a look at those maybe later. And of this page, with one eye on time, just recommend, see how this goes, to go to 3js.org examples. 3JS, as mentioned before, is a JavaScript library that's used in viewers. And the examples page, can everyone see that okay?
Yep.
Yeah, good. The examples page will give you some idea of the range of possibilities with 3D models, with scenes, with animation, with tracking the camera or not, and so forth. And really, it's a kind of taster of what is possible. And it's very broad. And all of this with open web technologies. So that will give you some idea of planning for the future. I think with that, then I'm going to stop sharing because we'll come back to that. So you can try that as we're talking. But it's now, want to open the mic on the virtual floor for a bit of discussion. Anything we've said so far? Anything about the community group, etc. And you can unmute yourself. You can put something in the chat area. We'll pause for a little bit now. Anyone? If not, that's okay. We can continue, and maybe you're busy with the first brief experiment, and let's say we'll come back for more. Without further ado, then, Julie, do you want to take over for a TSG update?
Sure. Yeah, I will take over from here. I will share my screen. And I will invoke the ritual. Can you see this fine?
Absolutely.
Yep.
As is the way of our people. Okay. So this I'm gonna handle sort of giving an update from the technical specification group, the TSG side, the 3D TSG side. And so, I know that that Glenn talked about this a little bit yesterday and that it's been mentioned already, but I just wanted to say, just to cover the bases, the 3D Technical Specification Group was chartered to help the editors basically draft updates to the presentation specification to add 3D support, to put 3D support into Prezi. The 3D TSG was chartered in December 2021, which it was originally chartered from the community group. A group continually discussing, and the community group thought that it would be really good to actually be able to have some of these things supported by IIIF specs. We put a charter document together, it was approved. So, and we meet every 2 weeks. So there is a link to that charter, which I think if a link to the slides has not already been distributed, it will be, so people can go back and check that out. And I will say that the TSG is pretty active right now. Most of the editors are regularly active in it, but we also have a large group of 3D specialists where some of those specialists are software developers, but not all are. We also just have, subject experts in 3D. And we have representatives from people who are both creating 3D content and developers working on 3D viewers, which some of those were already listed, but sort of in slightly more reverse alphabetical order. We have X3D, Smithsonian Voyager, Compact, IIIF Morphosource, Universal Viewer, which Universal Viewer can connect to Google Model Viewer or to IIIF. So Universal Viewer has some flexibility there. And we have been hard at work the last couple of years, both online, well, since 2021, so last 3 years at this point, both online, but we've also been putting in a lot of in-person FaceTime, thanks to IIIF funding, thanks to CREST Foundation funding, thanks to the Swiss data repository group. And so you can sort of see an outlay of some of the in-person meetings that we have worked on. And we are have produced and are continuing to produce a set of deliverables. So in January of this year, we put out the first sort of partial draft specification document. It's not a full copy of the Prezi spec document, but it does have sort of some of the first pass 3D features. So it's not everything we're doing, it's just the first round of features. We are continuing to sort of sketch out the 3D features that Prezi could support and how a manifest that would include 3D content would look. And so we are continually generating different draft Prezi manifests to figure out how that should be encoded into the presentation specification. And as of the working meeting in London, we reached what we thought was at least a start at a minimum viable product of feature recommendations and suggestions for implementation for the TSG to give the editors to aid in drafting Prezi 4, which I believe has been mentioned a couple times, that there is a suggestion that by June 2025 in Leeds that we will have a draft of Prezi 4 that will include the 3D stuff. And so if you're curious for more detail, I'm going to talk more about it, but there is a link in there to, I think it was just a report that I gave in one of our TSG meetings about basically the results of that London meeting and the determinations that arose from that. Okay, so the way I'm going to structure the rest of this is I'm not going to go sort of deep. I'm not going to do a deep dive into a lot of JSON. I instead wanted to approach this from the direction of sort of what can you do with IIIF 3D, or what are you going to be able to do? And so I'm going to structure the rest of what I'm going to say for maybe the next 10, 12 minutes around 4 things that we want you to be able to, and I'm going to think about stuff, because it doesn't really matter what the stuff is. The stuff could be 3D models, it could be videos, but we want to do things with stuff in 3D. What do we want to do, or what can you do? Well, you can first place stuff in a 3D scene. You can comment on stuff in a 3D scene. You can change the stuff that's in the 3D scene. And really combining all three of those first points, you can tell stories about the stuff in the 3D scene. So it's really like the first three build into the fourth. And I sort of underline the verbs because I think it's helpful to think about it from like a perspective of verbs. You know, what can you do? So, but before I do that, because I just repeated the word 3D scene a lot, and that's not in Prezi 3, it's not in the IIIF lingo a lot to this point. You know, a new version of Prezi that includes 3D is going to need to introduce a concept called a 3D scene, where a 3D scene is like a 2D canvas, but it has some important differences. Where a 2D scene is limited in height and width, a 3D scene, sorry, where a 2D canvas is limited in height and width, a scene is a boundless infinite space. Whereas the origin of a 2D canvas is in the top left corner, the origin of a scene is at the center. And when you are thinking of a 3D coordinate system, if you have done things with 3D before, just to check some bases of how that scene works, your up direction is your positive y-axis, your forward, so if you are a viewer, toward you, the viewer, is the positive z-axis, and together this makes it a right-handed coordinate space. And much like a canvas, you can place annotations inside a scene. And I also want to say, I want to give a small preview. There is a GitHub issue that I think is very worth looking at about saying, well, if we are adding canvas for 2D and scene for 3D, maybe Prezi needs a timeline class for audio resources. So if you just have an audio, a sound clip that does not have an associated 2D canvas, perhaps a timeline is the most appropriate way to encode that. But we're not going to get too deep in that. I just want to, if you haven't looked at the GitHub issue, I think it's worth checking out. Okay, so we know what 3D scenes are. How do you place things in a 3D scene? So we're going to accomplish that by adding a few new types of painting annotations that can be painted into the scene. Probably the big ones are 3D models, cameras, and lights. But you can also paint a 2D canvas into a scene. So if you want to create a gallery of paintings with, you know, a 3D model of a building filled with 2D images, you can paint those 2D images into the 3D scene. And you can also put scenes inside of scenes. So it sort of turtles all the way down, like we sometimes like to say, where you can have sort of child scenes or sub scenes or nested scenes that go inside of larger scenes, which that enables you to do things like if a museum has created a manifest that has a collection of one side of a chessboard, you know, all the pieces for one side of a chessboard, and a second museum has created a manifest that has the other side of the chessboard in different configuration, we can have a scene that has the whole chess game. We can put both of those scenes in one parent scene. And things that get painted into scenes, you can position them within the scene at any particular 3D point using a point selector. And you can also apply transforms, which again, if you worked with 3D, you've probably heard of translate, rotate, or scale in terms of translation. So you can use these to modify how things are positioned in 3D as well. Okay, so I think this covers sort of the basics of placing stuff in a 3D scene. So, okay, maybe you're thinking, okay, I can put my model in a 3D scene. What do I do next? Well, you can comment on stuff in a 3D scene. So, my VPN timeout. There we go. So this is an example from the Smithsonian of a batting helmet used in the 60s by Roberto Clemente for the Pittsburgh Pirates. Am I getting that right, Ronald?
That's correct. Thank you.
Thank you. Thank you. And they have annotated it. Now, in IIIF context, everything is an annotation. In IIIF context, the model is an annotation, and the labels are annotations. But people in 3D often talk a lot about label annotations because often you want to point to a specific part of a 3D model and say, this is the Pirates logo. This is the padding underneath. This is the helmet style. And so we want to be able to use commenting annotations, which already exist in Prezi for 2D, for 3D, which fortunately we don't need to add a lot of new features to make that happen. Maybe the most core one is that when you have a commenting annotation, you have an annotation body, which is your label. So maybe that's the text Pirates logo. And then you want to target that annotation at something on your canvas or in your scene. And so we need the ability for commenting annotations to basically to target a 3D position in the scene, which is easy. You just use the same point selector that you can use to put a model at a place in the scene. Or maybe we want to point that annotation at an entire model, but that's fine. That's really not very difficult. What gets a little more complex is there's a strong need to control what's called label body, either offset or orientation. So think about if you put two commenting annotations very close to each other in a scene, in a 3D scene, and they both have labels, you don't want the labels to overlap. You don't want one label to obscure the other label. And so it's very useful to be able to control how far off those labels sort of offset from the point. So in the pictured example, those are the orange lines. You can see the orange line going from the Pirates logo label to the actual point on the model that it is trying to annotate. And we are going to achieve this through introducing a new property that will apply to commenting annotations that are textual bodies. So commenting annotations that are just a simple text label, where essentially you will specify a secondary point, and that point tells you this is where I want the label to be placed. Or from your annotation target to your offset point, that also gives you a direction in space. It gives you a vector. So if you want to know, well, which way is forward for this commenting annotation, that also potentially gives you that if you are a viewer developer. Yeah, and a question that a lot of people ask next up for commenting annotations is, okay, so I can label a thing in the scene, I can pull my label away a desired distance, I can give it a direction, but can I customize the camera view? Can I say, I always want this annotation to be viewed from this camera angle? That is possible through something called content state, which we will get into just a little bit later. Okay, this is commenting on stuff in the 3D scene. Now, what if I want to change stuff in a 3D scene? And this is where we talk about content state. So content state is a IIIF API. It was the 6th IIIF API introduced. And the description from the API is it provides a way to refer to a Prezi resource or part of a resource in a compact format that can be used to initialize the view of that resource in a client. So content state is used to tell a viewer, I want you to load this resource in this state. So I want you to change the content. I want you to use this state to load my content. Now, if you go to the cookbook right now, the 2D canvas recipes that use content state do two things. They show you how to share a URL link to open a particular manifest with a specific viewer. So maybe I want to open this with Mirador and not with Clover, or maybe I want to open it with Clover and not with Mirador. Or how to open a specific region of a 2D canvas in a viewer. So if I want to open this 2D canvas and then I want to zoom into a particular square of the canvas, content state can be used for those, which that sort of goes along with this description of initializing the view, if you think about it like that. But content state can be used for a lot more. And I think in 3D, we're going to be making a lot of use of content state to accomplish lots of different things, and I'll show you a few. Okay, so I said I wouldn't get deep in JSON, but just to show you a little bit of JSON. A content state is itself an annotation with a motivation content state. So that content state annotation is the orange box that you are seeing on the right. The content state targets a manifest or something inside a manifest. So a canvas, a scene, a model, even, an image. And that target, which is the blue thing here, you can include new content for that target or change the existing content of the target. And so this is the content in blue. It's the content state annotation, points towards something in the manifest and gives you some description of what the content of that manifest should be. So a content state basically allows you to take a source manifest and then change it in some way, or initialize it in a different way than what the default state of the manifest is. To give a more concrete example, you can use content state to add a model to a 3D scene. So I'm just making some very simple diagrams of, manifests and scenes. So this is my default state. It's just an empty scene. I've sketched out a manifest. I've added an empty scene to it. There's nothing in there. And then I add a content state annotation that targets the scene and then changes the scene's items. So it adds a painting annotation. It adds a 3D model. And so when this content state is activated, the client that is loading the content state knows that it should change the empty scene and it should display the 3D model at the specified coordinates. So the content state is adding new content that was not previously present in the manifest. Content state can also modify the scene. So I've got my manifest 1, scene 1. This time I've put 2 items in, 2 3D models. And you can see both of the 3D models. So let's say I make one content state annotation that all it does is it goes to scene 1, it says painting annotation 2, that model, behavior hidden. So if you load this content state 1, only the first model will be shown because it hides the second model. And then my second annotation does the opposite. Second annotation only shows model 2 because it has set painting annotation 1, its behavior to hidden. So I can now toggle between 3 states, 3 content states for this manifest. The default where both models are shown. I can activate a content state that hides the second model and only shows model 1, or I can load a second state that hides model 1 and only shows content state 2. So this allows us to change stuff in our 3D scene. So content state, yeah, we can add content to the scene. We can remove content from the scene. We can change the properties of existing stuff in our scene. And I think the most reasonable question is, okay, maybe I'm getting how content states can specify changes, but how do I actually link the content state to the scene? What are the different ways that I can actually associate that content state with a scene? And we're going to use that. We're going to go and talk about telling stories about the stuff in the 3D scene, because this is where we get to that next level. And I'm going to explain how you associate content states to scenes, to manifests, through some actual use cases. Use cases where someone wants to do, interesting, innovative, advanced storytelling through, in 3D. So this picture on the right, you can follow the link. It's a demo that Ed Silverton made very early on in our 3D process called Infinite Canvas, which was really just a proof of concept to show that in 3JS you could combine a 3D model, your astronaut, with a video, which is a video of the moon landing, and then with 2D images pulled from art galleries, where the 2D images are being pulled from IIIF resources, just to show that you could put all of these things in a 3D space. So my use case in this is I have a 3D virtual gallery. It could look like Infinite Canvas. I could have recreated a building, but I want to show users different paintings. And so I want users to step between stages. Each stage is going to move the camera to look at one or more models or painting images. Maybe for each painting, I want to turn on multiple commenting annotations that weren't there previously. Maybe I want to change the lighting, etc., things like that. So a way that you can use content state to implement this, first, I create a manifest describing my virtual gallery in its initial state. Then, on the items of that manifest, I add one or more content state annotations. The content state annotation includes basically where I want the camera to go. It includes the commenting annotations that I want to show up for that particular painting. And then the users select from the content states that are just part of the manifest to reinitialize the viewer to their desired state. So this is a manifest that just comes with maybe a dozen content states. Users can click between them, and the state changes, the scene changes every time that they do. So I can go from stage to stage. My second use case, and you will notice there's a little bit of overlap with the first, is maybe I have a 3D model. So I have my batting helmet and I have label comments highlighting parts of the model. I want each individual comment label to use a particular camera view, and I want to change the lighting. So I want to be really specific. When a user looks at a particular comment, I want them to see a model from a particular camera view, and I want to change the lights. So how could I do that? Well, create a manifest containing my model and my commenting annotations. And here's where it gets different from the previous example. In this use case, for each of my commenting annotations, I'm going to use a scope property, and the value of that property is my content state, where the content state specifies the camera, the lights, etc. And I want to parenthetically point out that the scope property here, this is not new to IIIF. This is actually a standard part of the web annotation data model that IIIF is built on. So this is just, the scope provides context, essential context for viewing the annotation. So I am saying, I have a commenting annotation in my manifest. As a viewer, you need to know that to view this commenting annotation, there is some essential context to be able to view that, and that context is the content state. And so as users select commenting annotations, it will reinitialize the viewer to the desired state. It will change the camera view, it will change the lights, etc., etc. For my third use case, and this is where things start to get a little bit crazy, is maybe I want interacting with the content to change the content. So this is another sort of great demo that was created. There's a demo of a music box where the music box has an open box and a close button. If it is closed and you click open, the box opens, the ballerina starts to spin, and music begins to play. So let's say my use case here is not exactly the same, but it's close. So I have one or more 3D models representing a music box. When a user interacts with a button on the box in the scene, I want to play a sound and an animation. So there is an implementation for this, which is, so we're going to create our manifest containing one or more models. And we are going to introduce a new annotation motivation, activating, where an activating annotation associates the model for the button in the scene to a content state. And the content state includes the sound and plays the animation for the model. So when the user interacts with the button in the scene, the viewer knows if the user interacts with the button, which this could mean many different things. It could mean when the user clicks on the button, when the user taps on the button in a mobile context. Maybe there's a sidebar list of interactable elements in the scene that the user can interact with there. But when the user interacts with the button, it triggers the content state. It starts the sound and it plays the animation. So, and this is sort of like the last thing I'm going to talk about. It's reasonable for someone listening to be like, oh, so you are planning to implement annotations. We are considering for Prezi 4, so far our discussions are leading that we think that limited animation support should be in scope. The reason for that is that if you get deep into animations in 3D, things can get very complicated very quickly. So we're going to follow the model of something that's already in Prezi 3, content selectors, audio content selectors, and visual content selectors, which these allow a manifest to say, I want to annotate a video onto a canvas, but I only want to play the audio. Or maybe I only want to play the video and I don't want to play the audio. So we are planning to introduce a new animation selector that will allow manifests to target like a name value for an animation, which basically just as very minimal, very limited way to indicate to the client, we want this animation to play. But right now we're thinking that anything further than that, having the animation interact with the manifest timeline, is probably out of scope for now, but that's a good target for extensions or future versions or anything like that. Okay, and that's the end of where I am, and I think I will hand it back to Ronald.
Thanks very much, Julie. Let's pause for a moment if there are any questions, and then we can take everyone through a brief experiment before we call the hour. There was a question from Nora in the chat, which Tom and I tried to address a little bit, but the question was that what is the likelihood of having a IIIF 3D viewer that is universal? Well, I don't think that's necessarily a plug for the universal viewer, but you've already covered, Julie, Universal Viewer has 3D extensions such as LF and Model Viewer. But Tom, you rightly sort of said, well, exactly what do you mean by universal? What is worth saying is there will be a number of viewers. There are 2 viewer developers on this call at the moment, and we have others in the regular TSGs. And so, like, just as it is for 2D and audio video, people pick viewers on for a number of purposes, number of reasons. But we're probably coming to a place where it might help to think about having more than one viewer. This is a model that we see, for instance, from Oxford's Bodleian Library. For their 2D and audio video, they have 3 viewer selections in their digital library. The reason that's worth considering is because it will be a while before we sort of have enough of a merger between 2D and audio video capability and 3D capability. And yet we're making sure the viewers can handle a scene that has capability for 2D and audio video. So watch this space. But Nora, do you want to come back on that, or anyone else want to jump in? Okay.
Yeah,
Well,
so
please.
Ron, do you mind if I?
No.
Yeah, so just to follow up on that a little bit, I think it is interesting the differences in the web in general between display of 2D images and display of videos and display of 3D, because I think display of 2D images just in a very core sense is very baked into the web. Display of videos is less baked in, and there's like obviously, I think we all use like a profusion of probably different streaming viewer players that have different capabilities. But even still, with 2D video, there's at least like a core set of things I think that many people would agree are at least very helpful to have at minimum. I think 3D is another step beyond that, where people, I feel like even technical communities are still, even outside of the IIIF space, are trying to figure out what constitutes something that every 3D viewer should support. And so, yeah, I think we are likely to have a diversity of different 3D viewers. One of the things that I think is nice about the TSG is that we have a number of groups that are interested in, or have, I'll say, softly committed to adding sort of IIIF support to their viewers, like Compact, Smithsonian Voyager is interested in doing that, IIIF, the viewer that Morphosaurus uses, and so I think we are going to have good options, and I also think there's going to be a real strong place for integrating these viewers as extensions or functionality upgrades to sort of the big existing viewers that IIIF already has, which I think one of the benefits of IIIF is that you have content and you have multiple viewers. You have your universal viewer, you have Mirador, you have Clover, you have others. And so I think what'll be really cool is when we get sort of 3D added to all of those, and they may go about it slightly different ways, just like they go about other things in different ways. But I think the power of IIIF is being able to have one set of content that we can view across different platforms.
No, that's perfect. Appreciate it. Zoe, not to spotlight you, but I don't know if you want to come in on your thoughts from the compact viewer you're developing further.
Yeah, I can only agree to everything that has been said already. And I think in the end, it's if you are interested in showing 3D models on your own repository, there are different solutions comparable to you are searching for a complete repository where you can also store the data and everything and so on. But if you have a very concrete use case in mind, I would always say just reach out to us, ask us, and we can give you recommendations, or we can give you concrete ideas where you can, how to integrate your models in your existing repository, what kind of viewer you can use. And maybe we can even help in making a plan when you can use 3D manifests, for example, for your collection. So yeah, I think
No, that's great.
that's the good thing about being in such an experimental space, that the world is very small, and people are very willing to help and explaining your viewers, their specific viewers and software to you,
No,
at
it's
least from
perfect.
my experiences.
No, thanks, Zoe, absolutely. And Tom, your time with Sketchfab introduced people, maybe spoiled us a little bit, because the environment is both an editing environment as well as a viewing environment, and that is not as common yet. I don't know if you have any reflections on that whole world.
No, not really. None that, except to say that, I think we talk about kind of manifests and scenes, and from just personal experience, I think building a complex 3D scene is, done best in an editor that is designed to do that. I think writing a manifest in text and then testing it to see what it looks like in 3D and then jumping back between the two will be a tricky for other people, most people, I think, to do. And the fact that there are many editors out there already, for example, Blender or other 3D editing software, there's probably an opportunity to look at, well, how could they export a manifest and a scene? How could they reference IIIF enabled content from the web to help the people who want to do the storytelling part, but aren't so interested in the technical implementation of IIIF?
Yeah. Perfect. Yeah. If anyone has any further questions, do jump in. Nora, I saw your comment. Yeah, it'd be good to look more into what's out there, and that's what we'll try to help with. Regis, you, okay, good, it's clear. Thank you. Could you tell us a bit more about the most common file formats expected or recommended for 3D content in a IIIF manifest? Julie, you want to take a first stab?
Sure. Well, so I will, I will say that one of the nice things from our perspective is that the spec is going to be file format neutral, and the file formats that are usable is fundamentally going to be up to the viewer. So I think that'll once we start having more support, that's a really good question to check the viewer documentation for. And this is not a recommendation, but I can say that just in general on the 3D web, file formats like GLTF or its single file form version GLB. GLTF was created with the intent of being like a 3D JPEG type format for the web. I know that Apple devices are very much into file formats like USDZ, though that is a proprietary format and newer, so a lot of older tools don't support it. And I will say a very common file format often gets used are OBJs, often with like sidecar files for 2D image textures. So that's just as a 3D beginner, I think those are some of I'm sure others might want to jump in and talk about their favorite file formats, but I think those are some of the more common and worth looking at for 3D beginners.
No, it makes sense. It's probably worth pointing out, Tom had pointed out we are in contact with the USDZ community. That is actually an open format also.
Oh, I apologize.
No, it's quite all right. But we're going to be spoiled for choice for that. But those who have been more used to or have seen more about OBJ, PLY, STL, those came up particularly and are still used for 3D printing, but there are a number of others, FBX, etc. The Library of Congress in the US is slowly expanding. They catalog us as the British Library. We have representation here. Which formats are workable and also have some longevity to them. Some of these file formats come and go, which is part of why we try to promote not only open web technologies, but open file formats. And although we can say more about that, it is neutral, as Julie said. The idea is that the viewers handle much of it. We don't have a lot of time left, but I'm going to take a stab at something. Just want to show you for later. And we can make sure you have a link to the slides. But you might want to have a look at some of the experiments that have been part of it. X3D is another file format that is about the oldest around. It's about 30 years old. It's the inheritor of the VRML. It's on its 4th ISO standard update, and they helped TLTF get an ISO standard last year in the summer. But among these brief experiments, there's an online viewer to give you a hands-on flavor if you haven't tried it before. There's a link to load an astronaut model that we've been using in a lot of our examples. And so this is the 3D viewer directly calling up a file stored somewhere else, in this case, GitHub. Here's another example, number 2, that presents that view that has been altered. So I'll bring up the simple view. And when it loads itself, so you can do, I'm clicking and dragging, you can change direction and so forth. And a little tip, if you go into the share and copy the embedding code and take away the extra bits, you get a link. You'd have to look at it. We're running out of time, so I won't do too much. But you can get the basic details. So that's what this link is. It's without an embed code, just what's the link with all of the arguments that say, change the perspective, change the zoom, and what you get is, now you're looking from on top, and I'll go back, and there's one more example that then zooms in after I've rotated and zoomed and looking at the glove. And so all of this is the same model, just from different points of view, and by changing the link, by adding extra bits to the link. This is something that is commonly used in 2D, but it's going to be very important in 3D. And with that, make sure you want to check some of the other examples. And we've come to the hour. Any closing comments or questions? And if you don't have to run off, some of us can stay. Well, before everyone does run off, I want to thank Julie and Tom. Good working through all this together. And
thank you, Ronald.
Thanks. And Zoe, thanks for your contribution. There was a pointer to a experiment with Apple Vision Pro, which Michael Appleby, who was on this call, had done. Shout out to you. And make sure, if you don't have a copy to the slides, give us a shout and we'll make sure they are there. Caitlin, do we need any wrap-up things? Maybe not.
Sorry, no, we're good. We have the next session starting in 1 hour. So if you do not have the link for that, please let me know and I'll get you where you need to be. Other than that, we'll see you then.
Okay, and I'll put a link to the slides. Oh, thanks, Tom, you've done it. Okay,
Got it covered.
perfect. We're synced.
Well,
Great.
thanks, everybody.
Thanks, everyone.
Thanks all.